Hello, good morning, good afternoon, and good evening. Today we're going to be looking at a piece of software, LM Studio, Language Model Studio, maybe Large Studio, but I think it's more likely to be Language Model Studio. And we're moving forwards our understanding of working with local large language models on our own machines. We've had a little look at Ollama, kind of the gateway in. We've had a look at Open Web UI, understanding the components and how they piece together. And now we're going to look at what I feel is one of the more useful pieces of software, better user experience, better model download capabilities, easier chat interface, more user-friendly tool implementation and model settings to ensure that you really can get the most out of your machine hardware and also the model that you're going to run. So just before we take a little look at LM Studio, where can you find it? You can jump onto Google, LM Studio is going to pop up here. Run AI models locally and privately. So we have this here. You can download it for Mac. If we just top over here, you can download it for Mac, but you need an M series chip. You can download it for Linux, x86 or ARM64, and you can for Linux architecture as well. So whatever you're running for your operating system, LM Studio is going to be compatible. Unless you have an older Intel chip Mac, you need an M series. So that's how you can get LM Studio. Once it's downloaded, just head over and it'll pop open like this. The first thing that we're going to do, because it's a little bit dark, is we're going to hit this settings tab on the bottom left. We're going to go over to appearance and we're going to change it to light. And we're also going to change the navigation bar position to top. And it's going to make it a little bit more friendly for us. We're going to get to see the text instead of the symbols. So LM Studio is really simple. There's three parts to it essentially. There's the chat window, there's the server window, there's the models window. Okay, as you can see, I've got a few models already loaded up for us to have a little look at, and on the right hand side we've got update available. We've got the downloads of the models as they're downloading. We can just hide that away if we want. And the last window, the most important here, is the model search window. And this is the main reason. There's a few different reasons, but this is the main USP, if you like, of LM Studio. It's got a much more sophisticated model search engine, I suppose. And we'll go through why that is. The first thing that we can really notice when we're looking at the model downloads is we have this likely too large, full GPU offload possible. Let's see here, what else do we have? Full GPU offload possible, partial GPU offload possible. So we've got these little tags: vision, tool use, reasoning, the amount of parameters, architecture, domain, format. Okay, so we've got understanding of the model before we download it, which is something you don't have on Ollama, and it's something you don't have if you're just on HuggingFace, for example, open source website for looking for large language models that we'll touch upon a little bit in this episode today. So how can it know what the, if we pop up here, how can it know what the best match? You see, we can search by best match, most likes, most downloads, most recently updated, and we can only include star fits to ensure that maybe we're not downloading anything too far off the beaten track. And we can also search by GGUF or MLX, that's the file type. I'm going to leave it up here as best match. So the question is, how does LM Studio know what hardware specifications we have running, and therefore what the best match of large language model is for us to download? Well, if we head over to our settings, but you can also click Command Shift H if you're on a Mac, it will open up your hardware. CPU compatible, information detected about your CPU, and over here, memory capacity, the estimated total amount of memory on your system. So LM Studio runs a hardware assessment on your device, on your machine, and it identifies the CPU, M1 chip, the architecture, and the memory capacity. Okay, so I've only got a bog standard little machine here that we're filming on today. 8 gigabytes of RAM, Apple M1 chip. Is most likely you guys at home watching this video have something similar, if not more sophisticated, and excellent, and a GPU detected with metal. We've got a resource monitor down here, which is the best approximation. And down here, we can stick some guardrails on. So I've got mine set on strict. I think this is the default setting. So this essentially tells LM Studio, if you believe a large language model running locally will crash the machine in some way, take a precaution against it and don't run that model. Now, you can turn it off, and it could be useful in some ways. You could relax it, balance it, and that way you can get a little bit more out of the large language models. You can kind of push the boundaries of the hardware capabilities you have on your machine. But for our purposes, we're going to keep it on strict. And the reason that is it keeps the large language models running quickly, and it means that we're not... it's almost like over revving a car. We don't want to damage any of the parts. I mean, that's a bad analogy. We want the car to run efficiently and smoothly, and we want the best performance out of our vehicle. And for that reason, we're going to keep it on strict. Only large language models that can run efficiently will be run under this guardrail, as opposed to perhaps ones with incredibly long inference times or tweaking around with settings, so forth. So the first major difference between Ollama or Open Web UI is that you can select the models based on the search engine, which assesses the hardware capabilities you have on your machine to provide you the best matched large language model that you can run locally. And you can also use this staff picks to ensure that it's a popular model that's been tried and tested. We're going to go for Nemotron 3 Nano 4B. It's fairly new, 80 days ago. Relatively new from a large corporation that's reputable, and we've also got 170,000 downloads, so it's perhaps not anything unusual going on within the model. So essentially, let's take a little look. So let's just before we move on, let's have a little understanding of what we actually mean by the parameters, the architecture, the capabilities, vision, tool use, reasoning, what this means here, full GPU offload possible, and the like. So let's just jump into... Let's take a little look at what we mean by parameters. We touched upon this in previous episode. The parameters are the numbers that make up the model. They're actually what consist inside the gguf file, just lots of numerical parameters. And essentially, it's individual numbers that define how a model thinks and responds. You can think about it, the parameters being equivalent to neurons in a brain, and the more connections, the more neural connections the brain has, the more complex and nuanced the brain's thinking is. In a similar fashion, the more numerical parameters inside a large language model, the more nuanced and capable the thinking of the the large language model is. A 70 billion parameter model is around the same ballpark as 86 billion neurons in the human brain. Okay, so that's incredibly sophisticated. And one thing I like to think about actually is you can run a human brain on an apple and a glass of water, but to run a 86 billion parameter model, you'd need significant amounts of electricity, hardware, and so forth. But that's just an interesting comparison to make, and maybe we touch upon that in a moment as well, and how we have been created and come around. But first and foremost, if we're comparing what it's useful for in terms of parameters, which is a crude measurement, because you can have a large parameter model that's been trained badly, and you can have a smaller parameter model that's been trained quite well. But as a little rule of thumb, 1 to 3 billion parameter model will be good for phones, low power devices, and simple tasks. 7 billion parameter model is going to be the sweet spot for home laptops and machines. 13 billion parameter model will be good for GPU or 32 gigabytes of RAM. So we're really stepping up now. We're thinking about either a built machine or thinking about stacks. 20 billion parameters, enthusiast territory. 70 billion parameters, we're looking at an AI stack essentially to run that. So when we're seeing parameters popping up here, 5 billion params, 4 billion, down to Qwen here, 9 billion. That's what we're thinking about. The amount of numerical parameters inside the large language model's GGUF file, and that those parameters are equivalent to the amount of connections inside the large language model that enables nuanced thinking to take place. And we can compare parameters to neural activity in a human brain. And the area we're going to be looking at is probably 4 billion parameters to this Qwen here, 9 billion parameters, although that's a little bit of a push. So that's the kind of ballpark we're thinking about when we're just on home machinery, unless you have more capable hardware. Quants, so we see down here, let's have a look for some quant tables, and we can have an understanding of quants. Let's pop over to let's pop over to recently updated, and we put in HuggingFace. Okay, so here we go. So we've got BF, Q8, Q6, Q5, Q4. Let's pop over to here, and we've got Q2, Q3, 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 Q4, Q4. Okay, down here, there we go, F16, Q8, all the way down to Q2. What do we mean by that? First of all, what's HuggingFace? We'll have a full explainer in a little moment or two, but HuggingFace is essentially a directory where you can explore and download large language models to be used locally. So one thing to just think about is there's not many security vulnerabilities in downloading a GGUF file. It's essentially a load of numerical parameters that have been weighed. But as we're understanding and progressing further through large language model research, and more importantly implementation at a local level, a home level, and a commercial level, there are things to consider, and that's why the staff pick section is really useful, not only for LM Studio but also on Ollama, because it means that the large language model you are downloading onto your machinery is in fact tried and tested, and it does come from a reliable source, which is always important whenever you're downloading something from the internet. But as we can see here, Zed Hukes has got some security research, which is a GGUF parser integer overflow and division by 0. Essentially, without getting into it too much, running this gguf file could crash or corrupt a system or a machine. It's been put up here as a security research, which is aimed to let the large language model, local large language model community, AI community, understand that there could be security flaws in certain gguf files, and basically to take consideration to what you implement on your machine. Make sure you understand what you're running on your machinery before you run it. Use reliable sources, and to essentially move the needle forward in improving security for large language models. So I just thought I'd touch upon that because it is important to consider. So if we just head back to looking at some of those quant values, so BF16, Q8, Q6, Q5, Q4, what does all of that mean? Well, let's head over. So quantization makes models smaller, faster and smarter, and it supports your ability to run it on home machinery, local machinery, without needing a huge AI stack or a data center to run some of these models. Quantization is a full precision model stores every parameter as a large, highly accurate number, enormous file sizes, massive RAM requirements. Okay, so that's down here, our F16 full precision. This is like the full version, and we can see a BF16, a little bit different, but we can see that represented there. When we run quantization, it compresses those numbers down to smaller numbers, which are less precise versions. So each time quantization occurs, you lose a tiny sliver of quality, but the model becomes dramatically smaller and faster and able to run on different machinery. Okay, so if we're thinking about F16 full precision, so you need a proper stack to run this on. You can then quantize it, run a quantization process, which will take it down to Q8, Q5, Q4, Q2, and each time you run the process of quantization, it's represented in this shorthand quants. Quants 8, Quants 5, Quants 4, Quants 2, and it's essentially telling the user, us, who is looking to download or search for a model, the amount of times the full precision model has been compressed in order to facilitate easier use on lower capacity machinery. You also have I quants. I can't remember what the I stands for now. Oh god, silly me. But essentially, I matrix. Here we go. I matrix quantization. And if we think about it, we have our F16 full precision. That's like a raw image that's been taken. We have our JPEG, which is being compressed down to support file memory when saving it to a computer or transferring it or sending it as an email. So it's nearly as good as the original, but it's just a fraction of the size. And then an iMatrix can be thought about like a smart JPEG. So it's compressed the important details more sharply than some of the lesser quality details. So if it was a picture of a human face, for example, it would compress the background behind the human more so than it would the facial features of the human in the picture, essentially. So this is what the Q's mean. It means quantization. What does quants mean? Quantization, it means compression. And how does compression support large language models? It means that we don't need the full F16, full precision large language model file, which would not be likely to run on local machinery, but instead we can compress that large language model down into a quants 8, a quants 5, a quants 4, a quants 2 compression level to run on local machinery. Okay, so the bottom line is lower quants is smaller, faster, higher quants is better quality. Okay, so choose the lowest quant compression that gives you the quality you need with the hardware you have. Okay, so quick summary when we're thinking about these models here, which one to download, available files we can see there. We're thinking about what is the most appropriate large language model. The large language model, for example, this one, Carbon, 500 million parameters, is, well, let's take this 8 billion one. So here we have, let's take this 3 billion one. So this has got 3 billion parameters. Okay, so each of these Q4, Q5, Q6, Q8, and BF16 are all the same large language model, Carbon. Okay, but they've been compressed to different sizes to support utilizing on different machinery for different purposes. So depending on what your hardware capabilities are, will most likely depend on what version of the large language model you have, and the version is a shift in quants, compression size. Okay, now for LM Studio, I recommend hitting download because it arranges the, well, perhaps not with recently uploaded, but certainly if you're in the best match category, and we can look at this partial GPU offload possible tag as well to understand what the best model and download is. So for our purposes, while using LM Studio, I recommend just hitting that download. But it is important to understand what we are talking about when we see the Q5 or when we see partial GPU offload possible. Okay, so when we're talking about quants, we're talking about compression to make files more accessible for different users and to make different large language models most appropriate for different machinery. Okay, now earlier on we touched upon a chocolate bar and a glass of water, or an apple and a glass of water being able to run a human brain in comparison to 70 billion parameters being the equivalent to 86 billion neurons, and how many how much water or power or electricity or hardware would be needed to run a human brain when you think about these large data centers and AI stacks that can only really do a fraction of human compute, at least in the most part. So that's an interesting thing to think about. We also touch upon here on compression, and if anyone knows in the audience watching what this is or this represents, yes, the answer is a fern, but what does it represent? It represents a Mandelbrot set. Each of these, oh God, I don't know what you would call it, parts of the fern, leaves, individual leaves, are made up here. So this is equal to this. What are you talking about, Joseph? You haven't explained that very well. Well, we have a lovely formula for it. Z equals Z squared plus C. This is a way of nature constantly repeating on a smaller or larger scale the same pattern. Okay. What does this have to do with quantization and compression? Well, we first of all have identified this from a man named Mandelbrot, who first observed these. It's called a Mandelbrot set, and what we're looking at is a fractal. But more, and it's a mathematical equation that's found in nature, and some refer to it as the fingerprint of God left in mathematics. We have others such as pi, for example, 3.14. But why is this relevant to compression and quantization? Well, the Mandelbrot set and the idea that nature can have a finite sequence of smaller or larger items or components or properties, for example, like a leaf. It doesn't have to be a leaf. If you take a tree line, for example, the Mandelbrot set is going to be found in the tree line, each individual branch of a tree being the sum essentially of the tree itself. And the Mandelbrot set is a simple equation repeatedly applied, which makes incredible shapes and patterns. The patterns never end, but they keep getting more detailed the more you zoom in. And they occur in plants, seashells, clouds, galaxies. Okay. The equation represents that much of nature uses this to create detailed self-similar patterns. And it's actually utilized in the mathematics of zipping up files. So when you take that huge PDF you need to send to your boss and you zip it up and send it over email, because the email says we can't send the full file on its own, it's too large. Well, when you zip that file up, it actually uses the Mandelbrot equation or something similar to compress the file. So the file can be 10 times smaller, but it actually contains the same information that when it was unzipped, and then you can essentially unzip it and have all the information exactly the same. So you can take one PDF document, you can zip it up, which compresses it, quantizes it. You can send it across the internet to another machine via email. That additional user can unzip that compressed file and can extract using essentially quantization compression in reverse to restore the files back to their original state. And that is this principle of Z equals Z squared plus C, the Mandelbrot equation. So absolutely fascinating that we see not only the observations of Mandelbrot being utilized in technological advancements to this day in 2026, but also that little fingerprint of God emerges twice as we start to look closer into recreating the human mind on a technological level. And that is that, to run a human brain, you just need an apple in a glass of water, but to run a equivalency in neurons would require huge data centers the size of cities and mass water and power supply. And I really think that comparison, it really hits home and lands with me, that to run one human brain, a natural brain, just is an apple and a glass of water, but to run a technological brain, it requires so much power, space, literal, not space above the atmosphere, but space in terms of I don't know what you would call it, geographical space, I suppose, space, on a 3D plane, to build these data centers, and not to mention the complexity of parts. Nvidia right now are building a co-designed stack to be able to be specialized for AI, and the amount of work that goes into that is just phenomenal. And we also see here, alongside that kind of energy comparison, we also see that we see the Mandelbrot set, a mathematical equation found in nature, left by a designer, being utilized in not only the compression of zip files that we all used to, even a kind of a layperson working in an office, but also within the artificial intelligence and large language model research and implementation as well. So absolutely fascinating. What else do we have here? Let's just nip back to our search engine. We also have, let's see if we can find one or two, context window. So here we go. The small models feature 128K context window, while the medium models support 256K, K being 1000. So essentially, what is context length? When we see context length, it's how much the model can hold in its attention at once. Okay, your messages, its replies, and any system prompt all count towards this limit. Once you exceed it, the oldest content gets dropped out. So if you have, for example, a 4K context length, very, very, very small. As we can see here on that Hugging Face search, 128,000 context window, medium model 256. So if we think about 128,000 being an entire book, we can see that even a reasonable model such as Gemini 4E2B, 5.18 billion parameters, fairly new, literally released a day ago, so I will download that later. Full GPU offload possible, so it's a perfect match for my machine. We'll have a run about that. It's only yes. I won't get too distracted. As you can see, the more recent models, incredible context size. So what do we mean here? When you're kind of writing your response in, or you're providing images, screenshots to explain something, data from a Word document that you want to let the large language model understand specifically for the task that you've set it, if that context length is incredibly short, as it goes through the the input that you've provided for it, it will lose out the oldest data first. So if you think about the start of the message perhaps, or the first file you put in, by the end file, if the context length is not large enough, it will drop out the first file that was put in, which is no use. So if we think about this, it's kind of analogous to short-term memory. A 4K context is like remembering the last few minutes of a conversation. 128K context is like having the entire meeting transcript in front of you. You can kind of draw from all of it. I think the analogy of short-term memory is not the best, because short-term memory and long-term memory and the working memory model is a little more complex in humans. But I think as a rule of thumb, it kind of brings an understanding to what we mean by context length. So keep in mind, more context is more flexibility and fewer I forgot moments, but it also means more VRAM usage and slower performance. Okay, so 4K is like a short conversation, 8 is like a longer chat, 32 is like long documents, and 128 is like an entire book. Okay, and lastly, we have model type tags and GPU tags. So if we head back over, we've got here capabilities, vision, tool use, reasoning, full GPU offload possible. If we head up to the one just above it, likely too large. If we head over to Qwen, we should, let's go down to one, partial GPU offloading possible. Okay, so these are our other tags we can use to understand what model to download for our specific machinery. The model type tags: instruct, base, reasoning, code, vision, embedding. It essentially describes what the model's capabilities are. Can it accept images as inputs alongside text? That's what the vision capability demonstrates as a tag. Embedding, not used for chat, used for search and memory systems. Code, can it write JavaScript, for example, that we're going to have a little look at in a moment or two. Reasoning, does it think step by step before answering? Is it just a raw model with no behavior? It just is pure token prediction, because essentially at the end of the day, that's what large language models do. It's predicting the next character that's going to emerge. It's not necessarily constructing the sentence, and perhaps we'd need a deeper conversation for that than today's demonstration of LM Studio. So file names often include these tags, so you know what the model can do and how it should run. So if we nip back over, that's this tool use and reasoning. So we know this model's been trained to use tools, and we know it's been trained to reason. If we pop up to one of these, we know that Google's Gemini 4E2B can receive images within its input, and it can understand them. So it's been trained on vision skills also. If we think about these GPU tags, where we've got here green, full GPU offload possible. we've got down here likely too large, we've got partial GPU offload possible. What does that mean? Well, that means full GPU offload possible means the entire model fits in the VRAM, fastest performance. Okay, you have got the hardware capabilities to run that large language model. The partial GPU offload splits between GPU and RAM, so it's still good, but it can't be contained solely by your VRAM. So you're going to need to offload a little bit onto the GPU, essentially, the graphical processing unit, and then CPU down here only, no GPU needed. It's slower, but it might run. And what we don't have here is likely too large, which essentially means it's not a model for your system. You're going to either need to improve your hardware, you're going to need to go and get yourself a stack, or that model's designed to be running in data centers with cloud inference as opposed to locally on your machine. So if we head back over to LM Studio, now we've understood the searching option. Let's have a little look how the piece of software runs. So we've got essentially three sections. We've got the chat section. This is similar to Ollama. Boot up a new chat, you pick a model, okay, and you go. It's as easy as that. We'll just delete him for the moment. We've got the server, which provides information about everything that might be going on. It's good to have a little flick through, but we're not going to spend too long looking at that today. But I do advise have a little flick through. What we will be looking at is this model information here. As you can see, as we touched upon before, the model's Nemotron 3, 4 nano, 4 billion parameter. The file is represented here. Format, it's a GUF file. It's been quantized 4 times, so it's been compressed 4 times down from the full precision model. Half, 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 so it's a quarter, okay. Architecture sitting on the Nemotron, which is a NVIDIA architecture. Can we see, just to be... and it's taking up 2.48 gigabytes of space on our disk. And as we can see here, the context length set to 4096, so 4000, that's very short if we remember. 128 is a full book, 4 is like a short conversation, but it can support up to, what is that, 100,000 tokens or whatever it is there. I can't quite see it. Like 1 million tokens there or something. So we could put those up to do that 128. We'll pop that up to 128 there, and we'll reload it. We will reload that, no problem. And then inference, this is what we're going to go through in a moment together. But first of all, let's just have a look. And then so we've got chat, just like Ollama. This is our actual user interface with the models. Server, this is where we can choose a model, load a model up, and configure it. We can understand the information, we can change the token size, the GPU offload also, and we can change the settings, which if you remember from Open Web UI in our previous episode, really confusing. What are these advanced parameters? What's all this in the workspace? You've got tools, you've got skills, you've got prompts, you've got parameters, all very confusing, very clunky. Open Web UI, a lot more comprehensive than Ollama, but less user-friendly than LM Studio. And we'll understand and look at that in just a moment. We've got our models here that shows listed under parameters, highest to lowest, large language model, what it is, how much space it takes up on our disk, and whether we want to load it up. So if we're Carbon, we can load it up here. Qwen, we can load it up here. Qwen, we can load it up here. Okay, and then the right hand side, this is our model search, as we've seen. This is our downloads, and we can stick this tab away as well. And then down here with our settings, again, general appearance, how it looks. Developer, I've left this off just for this today. Chat settings, model defaults, integrations. Okay, these are tools, and we'll look at this as well today. Much more simple than OpenWebUI. And then LM Link. This is to you essentially run LM Studio on one machine, a headless machine or a stack, and then to be able to connect with it on any computer around the world. So without further ado, let's just have a little conversation with Nemotron. As you can see, we've got the tools here. We'll touch upon tools in a moment. And we've got some presets, system prompt, and the like. So let's just pick Nemotron and say, hello, how are you today? And it's going to show our thinking. Stop for 1 second. If we're thinking about OpenWebUI, we were waiting for a little bit of time for the response. Okay, so similar to OpenWebUI exploration, we had that model as the baseline, above it the prompt, then the knowledge, then the tools, then the skills. Okay, and LM Studios kind of bundled that all into one instead of along a workspace. So Nemotron 3 Nano 4B, that is the large language model, but we're going to go ahead and make that unique for us and to essentially support it to be a more reliable model for our purposes and our uses. So we're going to change this to 128. In fact, we're going to change it to 64,000 just for today's video. We're going to head over and change our system prompts. Oh, God. Your name is Godfrey. You are a helpful assistant. Whatever you do, you must not make up information. Always be honest with the user. If you cannot complete a task, let them know. If you are confused, ask for clarity. Be friendly. Be oh God, what should we have? Useful. That's not the best prompt here, I don't think. Always talk politely. Ask if you do not know. Always think before you respond. Okay, so we'll just set that as our system prompt. You can set it for whatever you want it to be. Okay. Custom fields enable thinking, controls whether the model will think before replying. We can turn that off. So a moment ago, when we just saw it talking before it output, that's this enable thinking. I'm going to leave it on because, and then truncate. Is it going to show the whole internal thought process of the large language model's response? I'm going to leave both of these on because I want to see what it's thinking, but I also don't want it to take up the full page. So we're going to leave those two on. Now, temperature, we're going to, in fact, let's head over to here. So, inference settings. This is tweaking the personality of the large language model to make it more bespoke. So temperature, what we're looking at here is how predictable it's going to be versus how rigid it's going to be. So NVIDIA recommend a temperature of 1. So I'm going to pop it to 1. The less temperature, the more random its responses will be. Not random in terms of it's just going to say something completely out there, but the less focused on the input it received it's going to be. But it also means on less capable models, it's going to provide essentially you don't want it to have too high a temperature, because it may repeat itself, perhaps like I've done a little bit in this video as well. So maybe my temperature setting is a little bit high, who knows. So we don't want to limit the response. Context overflow, so if it goes over the context window, like how we described in the previous slide, it's gonna, instead of just ignoring the bit at the start, it's gonna make the bit in the middle of the input truncated, so compressed down essentially. So or you can have it as stop at the limit, so as soon as it runs out of context, it just forgets what's coming next. So we're going to leave it as truncate in the middle. We're going to leave CPU threads alone. Now reason parsing refers to is it going to think and stop thinking before it responds, and that's why we're going to leave reason section parsing on. So when you ask the large language model, can you do X, it will think, yes, I can do X, this is how I will do X, I'm going to start doing X, and it will pass that off and stick it in its own section, instead of asking the user or telling the user, yes, I can do that, would you like me to do it? It kind of does all of that thought process on its own. So we're going to leave reason section passing on. We've dealt with our temperature. We've dealt with our system prompt. K-sampling limits the next token to one of the top most probable tokens. So remember, when a large language model is producing an output, it's predicting the most likely next character or next word. So we're going to leave this at 40, but essentially, and repeat penalty is discouraging using the same token. So each token is essentially a predicted value, a statistical likelihood, and so we're going to discourage repeating tokens in order to get more human results, I suppose, and also less robotic results is more what I was looking to say. Is going to reduce the utilization of similar words and phrases. Presence penalty, I'm not going to stick it on, but those two go hand in hand often. So we're going to leave top P sampling, and we're going to leave minimum base probability sampling as well, as they are. But essentially, this is ensuring it's same as temperature, but not. It's ensuring that the model is going to be responding focused, but also and reliable, but also not in a repetitive manner. So I may be being repetitive as well. So we'll close that down. I think it's important though with these settings, because they can be confusing. You know, what does it all mean? And perhaps I should have got a. We'll do a whole video on the next video we'll do it on explaining inference settings and advanced parameters, to really get the point home and let it land what we're talking about here. But for now, we'll pop that down. Structured output, we can pop it on. We'll leave it off. And speculative decoding. Now, this is a really amazing part of LM Studio. We're not going to look at it today, but if we read how it works, essentially, we can give a large parameter large language model to our machine and a small large language model that's often of the same family. So if it's a large Qwen, we want a small Qwen. If it's a large llama, we want a small llama. And instead, so the larger is the main model, the smaller is the draft model. And essentially the smaller model produces the output that the larger model validates. And that way you use less tokens, less time, and less energy. If the smaller model writes something the larger model wouldn't say, then it doesn't use it, okay, essentially. But validating someone else's work is less heavy than writing your own work. So if the large parameter model, the heavier model, was creating the output, it would take more tokens, energy, and capability. However, if the small model produces the output that the large model validates, you're using the tokens generation of the small model, but you're validating it with the large model. And essentially, you begin using less tokens and less time to produce an output at the same level of integrity as if the larger model was just running all by itself. Absolutely amazing. And we will look at this in a different video again. So that's speculative decoding, and prompt template you can have down here as well, but we're going to close that off. So we've set all of that up. I don't want to not save it, so we'll load it. 64, we've got all of that down there. So we'll load that model up. Okay, that's the equivalent of save and continue on OpenWebUI. So we're already seeing that the user experience and the understandability is much clearer on LM Studio than it was on OpenWebUI. I mean, even opening it, you've got that GUI, that graphical user interface button that you can just click on your desktop. It boots up a piece of software that everyone's familiar with, instead of going into the terminal, opening a Python environment, serving it, going to a local host. There's so many more steps on OpenWebUI. But I think it's important that we looked at Ollama, OpenWebUI, and then LM Studio in the order that we have done. Ollama is the gateway into using and downloading a large language model locally for the first time. OpenWebUI, although it's more complex, it's understanding there are tools, there are skills, there are prompts, there are baseline models, and all of that goes into creating a personalized AI agent. And it gives you a little bit of some of the background behind it. And then LM Studio kind of ties it all in together. We've got the user interface and the software like Ollama, and we also have the complexities and personalization of OpenWebUI. So now that we've changed the inference settings, okay, we've got a prompt in there, Mr. Godfrey, and we've improved our context length. We're going to go back to chat. We're going to close this one off. We're going to open a new chat. We're going to pick our model of Nemotron. Oh, God, I don't know which one it is now. Let's ask him. What's your name? There we go. So we can see in that thinking, and again, you could turn this off as we saw in the inference settings, but it's good to see the thought process of the large language model, especially when you're running it locally. You've got to think that Anthropic's Claude or OpenAI's GPT, they're running on data centers, sometimes as large as a small city. I think Meta's AI data centers the size of Manhattan in New York. I might, don't quote me on that, but I'm fairly certain it is. And we can see my name is Godfrey. Nice to meet you. How can I help you today? Now, we can see that he's talking quicker, he's running quicker, and a lot more efficient than A, Ollama on its own, and B, OpenWebUI. Okay, so we can see that chatting with Godfrey, our Nemotron 3 Nano 4B AI assistant, as opposed to baseline large language model held locally, has these tools on the side, just under a little hammer, like we spoke about in the Open Web UI video. So like tools that the local large language model can use is like having a toolbox, a hammer in there, a screwdriver in there, a lawnmower, a strimmer, whatever it may be, a pen, a calculator, you know. And we can create presets down there. Look, we have our prompt loaded in already. But where do we get these tools from? JS Code Sandbox, really important, going to show you why for document creation and a whole plethora of things. But I think what people use Claude most for in a work or education setting will be creating a PowerPoint, creating a Word document, creating an Excel, being able to download those efficiently, use them in meetings, use them in videos, use them in printing something off and handing it to a colleague. So JS Code Sandbox, really important. You say, oh, why is that? Well, you can run NPM or Node and actually convert JS into PowerPoints, into Word documents, into Excel, and I'll show you a lovely website to do that with in a moment. So we're going to enable that. But first of all, where do we get these from? Well, if we head over to LM Studio, we can go somewhere called the Studio Hub. This is official. It's from LM Studio. It's from the LM Studio team organization. We've got a Wikipedia plugin here, podcast. We've got RAG. We've got JS Code Sandbox, OpenAI, Compat Endpoint, and Dice. We're gonna get Dice because I think it's quite fun. So we're gonna. It's easy. Run in LM Studio. Allow. It's going to take you back over to your software. You're going to click download. It's as simple as that. I know in Open Web UI, you click import and it comes in, and we're going to get this lovely little flick on and off switch. I just think in LM Studio, it's so much more user friendly and intuitive than it is in Open Web UI. And I think part of that is having to run things through the terminal. I think part of that is, I mean, in here, you know, I just feel it's a lot more intuitive, and the user design is more well done in LM Studio. So we're gonna enable Wikipedia, web search, and JS Code Sandbox. And we're going to try this document creation process out. So we're going to say, hello, Godfrey. Please, can you create a JS sandbox which is used to write up a Word document file on marine biology? Feel free to search the web or Wikipedia in order to get the information. Make it slick and professional for university level students. Don't overcomplicate the task. And see, this is where you would put this in a system prompt, actually. Don't overcomplicate the task. I will convert the .js file to Word document myself. Just write the JS code file before conversion would take place. I'll handle the rest. So we're going to write that in, and we're going to see what he's going to think about. But essentially, in LM Studio, everything runs quicker. You understand what models fit your machinery. The tools are more accessible. The settings, the inference settings, are not only easier to understand, they're easier to manipulate. And the AI agent, here we go. Proceed, always show, always allow any tool. I usually leave these things off, but for today, we'll click Always Allow. And we can see it searching Wikipedia. Query marine biology. Result. It's got the result here. Okay, so the model's thinking. It's searched Wikipedia. It's got a page. So web search, web fetch. If you think about the Open Web UI, how complicated it was to get web search and web fetch up and running with API keys and all the like, creating an account with this, an account with that, running the API back. It's all done for you on LM Studio, and it makes it a lot more usable for practical tasks and to actually get stuff done. And remember, the main reason local large language models are so much better is on your machine. You're not giving all of your data away to OpenAI, to Anthropic, to whoever it may be. You're running this on your machine and you're not paying for it either. All these tokens are coming from the compute power inside of your machinery. It's not coming from a large data center elsewhere. You know, just while this is creating the file, we got a few more parts of this video. This presentation is quite long, I appreciate. We're just going to run this sandbox and we're going to convert this into a document. I'll show you a nice document converter to use for large language models. And then we'll just take a quick look at HuggingFace in the model search. And then I think we'll wrap this up for today's video. So I think here we're just about to finish. Let's see. Or has he just started? He's just started, so we'll give him a moment or two. And he'll run this down. But as you can see, he's searched the web, he's searched Wikipedia, and he's got the information from there. He hasn't used Beerus's web search, otherwise it would have told us. We've got the rest of this. Here we go. Excellent. So we can see it's pulled out this JavaScript file here, which is excellent because we can use it for real purposes. So if we just copy that text, head down and open up the text editor and pop it in there, and if we click File Save it as test2.js, save it in there, Documents, we'll save it to our desktop, we'll click Save. Lovely stuff. And amazing website. You can take any JavaScript and you can just run it through. You get one conversion as a guest. I'm not logged into this account. I do have Pro, and when you come down here, you actually, when you log in and you get Pro with JS Converter, you actually get to upload any image, any asset. So that's MP4s, GIFs, videos, whatever. And it's actually amazing because Claude or ChatGPT, sometimes you ask them to make you a document. You give them all the data. They make a document up. They run out of tokens. They don't give you the download link, but they do give you the JS file in the sandbox. So you can just copy it in. Or you can download it on Anthropic's Claude. Just download the JS file and come to JS Converter and just drop it in, and it'll convert it up for you. There you go, conversion complete. One conversion used. So we close this down. We just drop you, and we can see somewhere. I don't want. There we go. Test doc. And there we go, it comes up Word document. So we can see that LM Studio, you really get to utilize it for work and education purposes much more efficiently than with Ollama. You can't get any coding sandbox to make actual reliable documents on Ollama at all. Open Web UI you can, but it's just slow. It's just janky. It's just laggy. It's just not what LM Studio is. I'm just going to turn these off for a moment because you can see that they're working. I don't want to confuse him. And we're about an hour and a quarter in, I think, now. So we'll start to move it to a wrap up. But what I really like about this, and it's great if playing any board games or something like that, there's a roll the dice toolkit. can you roll 2 dice at the same time and give me the result, please? You know, and he's gonna use that dice rolling tool, and he's gonna be able to roll the dice for us. So if you were, I don't know, playing a board game, you don't have a dice there, or you're playing a game virtually across the internet or on Zoom or FaceTime or something like that, you don't have to debate about who's rolled what numbers, you know, and oh, it wasn't really a 6, it was a 4 or something. You can just ask Godfrey to do it, you know, your personal AI dice roller. Which is I think fascinating, and it's not just limited to 6-sided dice either. It could be 20-sided dice or whatever whatever die you need rolling. So we just process that prompt. Roll the dice. He's thought about it. There we go. He's rolled 2 6-sided dice and he's rolled a 4 and a 5. So there we go. We can move 9 spaces along. So essentially, we've looked at the difference between LM Studio, Olama, and OpenWebUI. We've looked at the hardware assessment that enables LM Studio to understand what models are compatible with your system. We've understood how to search for a model. We've understood how to download a model. We've understood how to personalize a model in the inference settings within models, how to load one up, how to open a chat, how to head over to the LM Studio hub and download tools in order and install plugins, tools in order for your local LLM to utilize, specifically web search and Wikipedia search. It's going to be really important that your local LLM, in our case Godfrey, can search and fetch web data. And we've learned how to create documents using JS Sandbox and convert them with jsconverter.co.uk. Okay, so I think really if we just have a little pause for a moment, you know, I was going to show you the carbon model. I think we've gone on a little bit too long, but if you want to go on LM Studio and have a look and have a play around, you know, that's excellent. That's what local large language models are all about, pushing the boundaries and learning and developing further. So essentially in today's episode, we've learned how to download LM Studio. We've learned how to utilize the hardware assessment to find large language models that suit us. We've learned and understood how to recognize what models are useful based on quantization, based on parameters, based on hardware tags and capability tags. We've learned how to change the inference settings to make our local large language model a bespoke AI agent. We've learned how to download plugins and tools. We've also touched upon how to create JavaScript sandboxes and to extract that JavaScript and to convert it into Word, PowerPoint, or Excels. And we've also touched upon the breadth and depth of local large language models and the open source community of HuggingFace. It's been a long one today. So I hope you found this useful, and we will do a video on inference settings, I think, in its fullest, just a short one. Thank you very much, and I hope you've enjoyed the video. Ta-ra.